Hello students, in this video I am going to solve MBOSE class 10 2020 board paper. Here question number 1 is, what is the sum of the exponents of prime factors in the prime factorization of 98? Here 98 can be written as 2 49 ja 98, 7 7 ja 49. So 98 is 2 to the power 1 into 7 to the power 2. As in the question it is given sum of the exponent. Here exponents are 1 and 2. Therefore sum of the exponents will be 1 plus 2, that is 3. In question number 2 it is given that find the zeros of the polynomial 49x square minus 64. Now here polynomial is 49x square minus 64. 49x square can be written as 7x whole square minus 8 square. It is a square minus b square, which will give a plus b into a minus b. Now since we have to find the zeros of the polynomial, we can write px equal to 0. Px is 7x plus 8 into 7x minus 8. So either 7x plus 8 is 0 or 7x minus 8 equal to 0. 7x plus 8 0 means 7x equal to minus 8. So x equal to minus 8 by 7. Again 7x minus 8 is 0. So 7x equal to 8. So x equal to 8 by 7. Therefore zeros of the polynomial are minus 8 by 7 and 8 by 7. In question number 3 it is given for the AP 1 by 4, 1 by 2, 3 by 4, 1. Write the first term and the common difference. Also write the fifth term. So here we have to find A, D and the fifth term. Here first term is 1 by 4, second term is 1 by 2. So A is 1 by 4, D is second term minus first term, which is 1 by 2 minus 1 by 4. If we take the LCM, it will be 4. 4 divided by 2, 2. 2 1 ja 2 minus 4 divided by 4, 1. 1 1 ja 1. 2 minus 1, 1 by 4. Therefore, common difference is 1 by 4. Now we have to calculate the fifth term. Fifth term will be fourth term plus common difference. Fourth term is 1. 1 plus 1 by 4. Here LCM will be 4. 4 into 1, 4. 4 divided by 4, 1. 1 1 ja 1. 4 plus 1, 5 by 4. Therefore, first term is 1 by 4, common difference is 1 by 4 and fifth term is 5 by 4. In question number 4 it is given, if the altitudes of two similar triangles are in the ratio 2:3, what is the ratio of their areas? We know the ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding altitudes. So we can write area of first triangle by area of second triangle equal to altitude of first triangle square plus altitude of second triangle square. Here it is given the ratio of the altitudes is given 2 by 3. So it will be 2 by 3 whole square, which will give 4 by 9. Therefore required ratio is 4:9. In question number 5 it is given, evaluate cos square 42 minus sin square 48. Here cos square 42 minus sin square 48. This cos can be written in terms of sine. We know cos theta is sine of 90 minus theta. So instead of 42 we can write sine square 90 minus 42 minus this one we are not changing, it will remain same, sine square 48 degree. So here it will be sine square 90 minus 42 is 48. Sine square 48 minus sine square 48. Same value minus same, that means it will be 0. So the required value is 0. In question number 6 it is given that find the distance between two parallel tangents of a circle of radius 8 cm. Suppose this is the circle and these are two parallel tangents. Radius here is 8. So the distance between the tangents will be 8 plus 8, that is 16. So we can, the distance between the tangents will be twice r. Twice r means 2 into 8, 16 cm. Therefore 16 cm is the distance between the parallel tangents. In question number 7 it is given that if the diameter of a semicircular protector is 14 cm, then find its perimeter. Now it is given the diameter is 14, so radius will be 7 cm. So if you want to find the perimeter of this figure, for this part it will be pi r. We know circumference of a full circle is 2 pi r. So for half circle it will be pi r, and for this part r plus r twice r. So it will be pi r for the curved part, and for this straight line twice r. Pi is 22 by 7 into 7 plus 2 into 7. 7 7 cancel. So it will be 22 plus 14, which will give 36. Therefore perimeter of this figure is 36 cm. Question number 9. Find the value of k for which the quadratic equation 3x square minus 5x plus 2k equal to 0 has real and equal roots. Here 3x square minus 5x plus 2k equals to 0. If I compare with ax square plus bx plus c equals to 0, then a will be 3, b equals to minus 5 and c equal to twice k. Now for real and equal roots, we know d equals to 0. So b square minus 4ac will be 0 because this is the value of d. B square minus 5 square minus 4 into 3 into twice k equals to 0. 5 5 is 25 minus 3 4 is 12, 12 2 is 24k equals to 0. Minus 24k will be minus 25. If I multiply both sides by minus, then it will be 24k is 25. Therefore k is 25 by 24. Therefore required value of k is 25 by 24. Number 10. Find the value of x in sine of twice x equal to sin 60 cos 30 minus cos 60 sin 30. Here it is given that sine of twice x is sin 60 cos 30 minus cos 60 sin 30, and we have to find the value of x. So sine of twice x equals to, from the trigonometric table, sin 60 is root 3 by 2 into root 3 by 2. Cos 60 is half, sin 30 also half. So sine of twice x equal to root 3 into root 3, 3 by 4 minus 1 1 is 1, 2 2 is 4. So sine of twice x equal to 4 LCM, 3 minus 1. So sine of twice x equal to 2 by 4. If I cancel, it will be 1 by 2. Therefore sine of twice x equal to sine of 30, because sine 30 is half. Therefore twice x equals to 30, x equal to 30 by 2. So x equal to 15 degrees. Therefore required value of x is 15. Question number 11. We have to prove that 1 minus sin theta by 1 plus sin theta is sec theta minus tan theta whole square. Now here, since in the denominator it is plus, we have to multiply with minus. And if it is minus, this also will be minus. So here in the numerator it will be 1 minus sin into 1 minus sin. In the denominator it will be 1 plus sin theta into 1 minus sin theta. In the numerator 1 minus sin theta whole square. Here a plus b, a minus b, it will be a square minus b square. So 1 minus sin theta whole square, and we know sin square plus cos square theta is 1. So 1 minus sin square theta, it will be cos square theta. Because here you can write since sin square theta plus cos square theta equals to 1. So it will be 1 minus sin theta by cos theta whole square. So we can write 1 by cos minus sin by cos whole square. 1 by cos is sec and sin by cos is tan. So it will be sec theta minus tan theta whole square, which is the required right hand side. Question number 12. The line segment joining A minus 2,9 and B 6,3 is a diameter of a circle with center C. Find the coordinate of C. Here it is given that this is the diameter. A is given minus 2,9, B is 6,3, and we have to find the coordinate of center, which is C. Since center is the midpoint of this diameter, so by using midpoint formula, coordinate of center, which is xy, will be x1 plus x2 by 2, y1 plus y2 by 2. Here x1 is minus 2, x2 is 6, minus 2 plus 6 by 2, and 9 plus 3 divided by 2. 6 minus 2 is 4, 4 by 2, comma 9 plus 3 12, 12 by 2, 4 by 2 2, 12 by 2 6. So 2, 6 is the coordinate of center. In question number 13, it is given two vertices of a triangle are 3, minus 5 and minus 7, 4. If its centroid is 2, minus 1, find the third vertex. So here out of 3 vertices of a triangle, 2 of them are given, third one we have to find, and coordinate of the centroid is also given. Here x1, y1 is 3, minus 5, x2, y2 is minus 7, 4, and centroid is 2, minus 1. We have to find the third vertex, that is x3, y3 is to be calculated. Now we know the centroid formula xy is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. x1 is 3, x2 is minus 7, and x3 we have to calculate by 3, y1 plus y2 minus 5 plus 4 plus y3 by 3. Now 2, minus 1 will be 3 minus 7 is minus 4 plus x3 by 3, minus 5 plus 4 is minus 1 plus y3 by 3. Now 2 is equal to this part and minus 1 equal to this part. Now if we separate, for the first part minus 4 plus x3 by 3 is 2. So minus 4 plus x3, 3 to the 6. So x3 equal to 6 plus 4, which will give 10. Here minus 1 plus y3 by 3 is minus 1. Minus 1 equal to this. So minus 1 plus y3, 3 into minus 1 minus 3. So y3 is minus 3 plus 1, which will give minus 2. Therefore third vertex is 10 comma minus 2. Question number 14. The perimeters of two similar triangles are 25 cm and 15 cm respectively. If one side of the first triangle is 9 cm, what is the corresponding side of the other triangle? We know perimeter of first triangle by perimeter of second triangle is equal to the side of the first triangle by corresponding side of the second triangle. Perimeter of first triangle is 25. So 25 by 15 is 9 by side 2. If I cancel by 5, 5 5 is 25, 5 3 is 15 is 9 by side 2. So side 2 will be 3 into 9 divided by 5. 3 9 is 27 by 5, which will give 5.4. Therefore the corresponding side of the second triangle is 5.4 centimeter. PQ and PT are tangents to a circle with center O and radius 5 centimeter. If PQ is 12 centimeter, then prove that perimeter of the quadrilateral PQOT is 34 centimeter. In this question, it is given PQOT is a quadrilateral in which PQ and PT are tangents. It is given that PQ is 12, radius is 5, and we have to find the perimeter. We know length of tangents drawn from an external point to a circle are equal. So in this circle, PQ and PT both will be equals to 12. OQ and OT both are radii of the same circle, so it will be 5. So perimeter of the figure will be PQ plus QO plus OT plus PT. Perimeter means boundary. So it will be 12 plus 5 plus 5 plus 12. After adding, it will give 34. Therefore perimeter of the quadrilateral is 34 centimeter. In 15a, which is for the blind students, question is define a quadrilateral. In the second part, it is given a tangent to a circle is perpendicular to the radius to the point of contact. For the first part, we can write a plane figure bounded by 4 line segments is called a quadrilateral. And for the second part, a tangent to a circle is perpendicular to the radius to the point of contact. This is the statement of theorem 10.1. So it is a correct statement. In section C, first question is a construction. This construction I have done in the third part of my constructions of class 10. From there you can do it. Now see question number 16. First question is define radius of a circle. So here answer is line segment joining center to the circumference is called radius. In 16 second part, it is given in a triangle, if the square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. This is converse of Pythagoras theorem, so statement is true. The third part, a line which intersects a circle in two distinct points is called secant, so answer will be secant. In question number 17, it is given that ABC is an isosceles triangle with AB equal to AC equal to 13 centimeter and the length of the altitude from A to BC is 5 centimeter. Find BC. Here it is given ABC is an isosceles triangle where AB equal to AC and both are equal to 13 centimeter, and it is given that the altitude AD is 5 centimeter. We have to find the length of BC. Now here in triangle ABC, AB equal to AC equal to 13 centimeter, AD is perpendicular to BC and AD is given 5 centimeter. In right angle triangle ADC, since it is 90 degree, this angle is 90 degree, so we can use Pythagoras theorem. So it will be AC square is AD square plus CD square. So AC is given 13, AD is 5, DC we have to calculate. 13 square 169, 5 square 25, DC square. 169 minus 25 will give 144 is DC square. So DC equal to root over 144, which will give 12 centimeter. Therefore BC equals to BD plus DC, because both are equal, so it will be 12 plus 12, which will give 24 centimeter. In the second part, it is given that in the adjoining figure, PS and PT are tangents to the circle drawn from an external point P. CD is the third tangent touching the circle at Q. If PT is 10 centimeter, CQ is 2 centimeter, we have to find the perimeter of triangle PCD. Here it is given that triangle PCD's perimeter is to be calculated. We know length of the tangents drawn from an external point to a circle are equal. So here PS equal to PT, both will be equal to 10 centimeter. CS equal to CQ, both will be equal to 2 centimeter. And DQ equals to DT. Now we have to find the perimeter of triangle PCD. In triangle PCD, it will be PC plus CD plus PD. So perimeter of the triangle PCD is PC plus CD plus PD. Now instead of CD we can write CQ plus QD. So here we have written PC plus CQ, PC. Instead of CD we have written CQ plus QD plus PD. Now PC plus CQ equal to CS. Instead of QD we can write DT plus PD. Now PC plus CS will give PS and DT plus PD will give PT. PS also 10, PT also 10, so 10 plus 10 will be 20. Therefore perimeter of the triangle is 20 centimeter. 17a question is state Pythagoras theorem. So we know the statement that in a right angle triangle, square of the hypotenuse is equal to the sum of the squares on other two sides. In second part of question number 17, it is given if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So answer will be same ratio. Now in question number 18, it is given an arc of length 20 pi centimeter subtends an angle of 144 degree at the center of a circle. Find the radius of the circle. Here it is given arc length L is 20 pi centimeter, theta is 144 degree. We have to find the radius. Now we know length of the arc is 20 pi and we know the formula of arc length is pi r theta by 180 equal to 20 pi. Pi r theta is 144 by 180 is 20 pi. So r equals to 20 pi into 180 divided by pi into 144. Now pi and pi can be cancelled. If we cancel by 12 ja 144, 12 15 ja 180. This 20 and 12 can be cancelled by 4, 4 3 ja 4 5 ja. So radius will be 5 into 15 divided by 3, 3 5 ja 15. Therefore radius equal to 5 5 ja 25 centimeter.